Okay, so this is the other method I wanted to talk about. So sometimes vectors are given in this notation, right? And this is what we call component notation, I think. I might be getting that wrong. But basically, it's giving you the vector in the xy plane, right? So when you have that -2, 9, it means like -2x and a positive y, 9. And this one would be positive x and one in that direction, and then 1 in the positive y direction. Right. So if you want to calculate the sum of these two, you can just add the individual parts. Like for example, so it was -2, 9. That was 1, 1, right? And we want to add these two together, right? Well, the nice thing you can do is you can just add the x component and add the y component. So then it could just be -2 plus 1, which is -1. And then 9 plus 1 is 10. Right. And that would be the new vector. Is that clear?
Very.
Sweet. So, okay. Yeah. So that's for that one. But then sometimes you're given vectors in the term of magnitude. All right, sorry. I didn't start. Okay. So you're given vectors in the term of magnitude. So you'll be given a vector, and you'll be told its length, which would be a in this picture. But it doesn't tell you how far in the x or in the y direction. But it will also give you the angle of that vector. And the angle is usually, not always, but most of the time, traditionally, the angle is from the positive x axis going upwards. So if it's 30 degrees, it's going to be 30 degrees above the positive x. If it's 270 degrees, it would wrap all the way down and it'd be in the negative y direction. But usually to solve a lot of problems, you need to know the x component and the y component. And so these two formula up on the screen, it kind of tells you how to get each chunk or each piece of the component. So you just take the magnitude, which in this case would be a, and for the y component, you just do the sine. And then for the x component, you're just doing the cosine. And that kind of gives you each part separately. So now I'm going to give you guys another practice problem. I think I'm going to give you guys a few minutes just to try it out on your own, and then we can go over it together.
I'm ready when you are.
We're going to turn that over. Okay. So I'm going to. Okay, so it was, oh, sure, then right down the numbers. But it was, the magnitude was 8, right? We'll call this one A. So the magnitude was 8 at an angle, let's see, what was the angle again? 30. Okay.
Yes.
Angle of 30 degrees. And then we'll say this one's B.
And that was
Oh,
5.
this is VW. Oh, sorry. So 5 at angle
160.
60. Sweet. So in this case, you just plug them straight both into the calculator. And you would just basically, for A's y component, we would have 8 times the sine of 30, right? Which I think is going to be 4.
I got 4.
Sweet. And then A's x component can be 8, the cosine of 30.
I got 6.92.
6.92. And then we got B's y component. It's going to be, 5 times the sine of 30. Oh, no, sorry. 160. Which I got 1.71.
Correct.
And then the x component, 5 times the
And then I got 4.7 for that.
4.75.
Yep.
Okay, so did you enter in cosine 160?
No.
Okay,
I forgot
so,
the y.
okay, so one of the things here is you want to make sure you enter in the actual angle, because it's supposed to be negative 4.71. Wait, no.
It's going
0.7.
to be, yeah.
Yeah. Because
Right.
then that gives the correct direction of the vector.
Gotcha. Okay.
Mhm. So then when we add all of these together, and I'll just say V plus W, since that's their actual names. The y component is going to be 5.71. And then the x component, sorry, just going to look at it real quick. It's going to be 2.22. Now the neat thing here is that we can actually use Pythagoras' theorem. I'm not gonna spell that actually, I don't know how to spell it. But you could just do 5.71 squared plus 2.22 squared. And that's gonna equal, we'll say the magnitude, and I'll just call it C squared.
And it should be 6.12.
6.12?
Yeah.
Sweet. Okay. And then to find the angle, you would just do the tangent inverse of the y length, because we're doing opposite over adjacent. So that would be 2.22 over 5.7.
Can you scoot up the paper a little bit, please?
Oh, sorry.
You're fine. So you said C is the tangent? I'm sorry, not tangent, the magnitude?
Yes.
Okay.
So that would be the magnitude.
And then
Again, sorry for my terrible handwriting.
you're fine. It's easier than most.
So, and then the angle. So let me draw this up. So this is like C. And we'll say, well, it's really called V and W. And we have this angle. And we know, the tangent of that angle is going to be equal to the opposite, the length, right? And you use the absolute value sometimes to mean like magnitude. So we know that the angle is going to be equal to the tangent inverse of those magnitudes, which is 21.25 degrees.